Hello everyone. My name is Cecile Malonda, and in this presentation I will discuss the concept of tiles of graphs and graph theory. This topic explains how a small graph structure can be used as a building block to construct larger and more complex graphs. Throughout this presentation, we will explore the definition of graph tiles, examples, construction methods, and their applications. Before discussing graph tiles, let us briefly review the concept of a graph. A graph is a mathematical structure consisting of vertices and edges. Vertices represent objects or points, while edges represent connections between those objects. Graphs are widely used to model transportation systems, social networks, communication networks, and many other real-world structures. Understanding graphs is important because graph tiles are built from these fundamental elements. A graph tile is a small graph structure that can be repeated or connected with other graph tiles. The idea is similar to floor tiles used in buildings. A single tile may appear simple, but when many tiles are combined, they create a larger structure. In graph theory, graph tiles provide a systematic method for constructing larger graphs while maintaining a consistent pattern. This makes large graph structures easier to study and understand. Here we can see a simple example of a graph tile. This tile contains three vertices labeled A, B, and C. These vertices are connected by edges to form a triangular structure. Although this graph is relatively small, it demonstrates the key idea behind graph tiles. The pattern can be copied and connected to other tiles to create larger graph structures. This ability to repeat a pattern is the foundation of graph tiling. Let us now observe how a larger graph can be constructed from graph tiles. We begin with a single tile. Next, a second tile is connected to the first tile. Then, a third tile is added while preserving the same arrangement and connection pattern. This process can continue repeatedly. As additional tiles are attached, the graph becomes larger and contains more vertices and edges. Even though the graph increases in size, its overall structure remains organized because it is built from the same repeating pattern. This is the central idea behind graph tiling. Graph tiles provide several important advantages. First, they simplify the construction of large graphs because the same pattern can be reused multiple times. Second, graph structures can be expanded easily by adding new tiles whenever necessary. Third, the repeated design makes graph analysis more systematic. Finally, graph tiles allow researchers and engineers to build complex systems from simple components. Graph tiles have many practical applications. In network design, repeated graph structures help create reliable communication systems. In computer science, graph tiling can represent large systems using reusable modules. Similar ideas are also used in circuit design and engineering applications. In mathematics, graph tiles provide a useful framework for studying large and complex graph structures. These applications demonstrate the importance of graph tiling in both theoretical and practical fields. In conclusion, graph tiles are small graph structures that can be repeated and connected to form larger graphs. They provide an efficient way to construct, organize, and analyze complex graph structures. Because of their flexibility and simplicity, graph tiles have many applications in mathematics, computer science, engineering, and network design. Thank you for your attention. I hope this presentation has helped you understand the concept of tiles of graphs and graph theory.